Hello, sir. Good morning, sir. Hello.
Good morning, sir.
Good morning, sir. Good morning, sir. Very good morning to all. Today is the last. Today is the last day. So I have to breathe and after this, all are in the very busy schedule. Okay. Today, our resource person, Mr. N. Sharat Chandar Nadarajan, is a co-founder of MaxCAD Coimbatore. He is BE in Kongu Engineering College, Erode, and MSc Mechanical Engineering in North Umra University, UK. MSc Applied Psychology, Bordey University, Coimbatore. And he has a membership chartered engineer, the Institute of Engineers, NatWillets Startup Circle, Coimbatore. His experience, research and development in Granger in Industries, UK, IBM Mainframes Programmer, Mapless ESM, Chennai, Design Engineer, Saubhagya Wet Grinders, Chennai. And he has a current research area in IoT, in defense, agriculture automation. And he has a author of FEA, CFD, and has a career guidance. Now we are going to take a topic on Innovate with 3D printing. So please, sir.
Good morning, all.
Good morning, sir.
So I'm audible, right? And you can all see my presentation. Yeah?
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Audible, sir.
Good morning, all. I'll start with again a small recap of my introduction. I did my masters and I did my mechanical from bachelor's from Kongu, and I masters from North Umbria University. That is on product design and development. And my core area of interest is actually computational fluid dynamics and finite element analysis. Currently, I own a company called MaxCAD, which is into engineering services and technical training. And we also co-founded a couple of other companies related to 3D printing and other allied services. Before getting into my presentation, usually I have a habit of telling stories. Today, the story is chained elephants. So this story is very much related to what we are going through right now. The story goes like this: a foreigner is going around India on a tour, and he can see that when he goes to Kerala, he can see that a lot of elephants are carrying big logs. They are pulling lorries. They are pushing big rocks and everything. But when he visits a temple, he can see that the elephant is tied to a chain, simple chain. So he couldn't believe how come a simple chain can hold this mighty animal. So he asked the keeper, and the keeper says that they practice the elephants since the childhood by tying them to a chain. So during their childhood, they cannot break their chain. Even after they are grown up, they still believe that the chain is tied to them and it cannot relieve from the chain. That is how the elephants believe themselves that they cannot break the chain. So why this story is because most of us in current generation, we are all brought up by a chain tied to our leg. So if we during our school days, if we ask questions, they will say that it is not to your standard. Please don't ask like that. If we try to do something above our age or think differently, people used to stop us or control us. But this is not, this type of chain has to be broken, and all your thoughts, innovation and everything should come outside. So even today you can see that when an ISRO program is being done, then the number of output research from that ISRO program or the university's related outcome study outcome are very less. This is because of the chain, something that is holding us. So we should break the chain and we have to come. This is very much required from this century onwards. For example, COVID, which is a very unexpected thing. Each and every place, every news has a word called COVID, which was not there in 2019. In similar way, most of our day-to-day or our career is going to be completely changed. So we should be ready to break the chain and change, ready for the change. So with this presentation, I would start comparing with you industry 4.0. I'm sure that most of the topics are being covered for the past 4 days. Still I want to recap and connect the topics towards innovation. So most of us think that industry 4.0 is a current version, right? So when we take industry 4.0, most of us are supposed to interlink our departments. So a mechanical graduate should know something about programming, circuit designs, and sensors. Similarly, the electrical student should know about mechanical. Similarly, the computer science student should know something about electrical and mechanical. Everything, like all your departments, should be interlinked. Why it is? Because how these industry 4.0, how we achieve this. So for example, these are the different industrial revolutions that we came across. So first industrial revolution that has happened, like in terms of happening, is on 1765, where mechanizations happened. So we instead of a bullock cart, we wooden bullock cart, we introduced bullock carts with a wheel, metal wheel, and other things, or a small mechanism has been added. So in all the process had been given some engineering concepts to it. So that is a first revolution. The second revolution is mass production, from a small manufacturer to a larger manufacturing, like in terms of production floors, assembly lines kind of stuff, is what we call it as industrial revolution 2.0, which happened in 1870. The other thing is automation. So due to increase in demand, we started automating some of the manufacturing process. That happened in 1969, and today, that is like in 2020, we call it as industry 4.0, where data play a very important role. Electrical sensors, data collection plays a very important role. With that data, we are going to process a lot of information, and with that information we can provide an efficient output. So for example, from industrial revolution 1 to 2, it took 105 years. From industrial revolution 2 to 3, it took 99 years, and industrial revolution 3 to 4, it took 51 years. See, the gradually the gap between the revolutions are being shortened up. And the other most important thing is, 1 minute. The other most important thing is what happened in between this 51 years. This is very important. When we see in first 105 years, the number of innovations were very less. In the next 100 years, the innovation started growing a little bit. And in the last 51 years, you can see a very big growth in terms of number of innovations. I'm talking about the products and the evolution of a product. For example, most of us know how we used to buy audio cassettes. Like we buy magnetic tape cassettes for audios, right? So whenever a movie releases, the audio shops, they will sell magnetic tape cassettes. We can buy it and we can play it in our tape recorders. So the radios and everything we can play. In our generation, we can see that the magnetic tapes are replaced by compact disc, and then it has been replaced by DVDs, where a single storage, the volume of storage increases. The other thing is, from DVD we directly jumped into solid storage devices like iPads and iPods. From iPads and iPhones, and then all our mobile phones, everything has a solid state memory where we can store all our music and we can listen it to it at any time at anywhere. Now the generation is completely changed. You don't need any storage at all. The cloud, in the cloud, it has been stored in a larger storage place. All the music, videos, and everything are being stored. And if you have a device which is connected to the internet, you can just hear them. You don't need to even download them. Correct. So we can see in a very short, I would say in last 30 years, there was a very big drastic growth in a single segment. Similarly, you take any field, there is a very big growth or a very big leap in their process. So this is where the industry 4.0 plays a very important role. So even when we talk to couple of people, the mechanical people, if we say, sir, industry 4.0, they will say that only additive manufacturing and robotics are related to mechanical. No, that is not the case. So it is all integrated. So everything has been integrated, and the other thing is something called as 21st century skill set. We will see it at the end. Okay, what is 21st century skill set? So if we want to achieve a $5 trillion Indian dream, we should have higher innovation rate. The I would say a basic example, like we all have televisions at our home. Most of us will have LG, Sony, Samsung, all those kind of televisions. We have forgotten Indian television companies like BPL, Onida, and other companies. They failed because of innovation. So the constant innovation is very important to sustain our product in the market. So Indian companies are lagging. Indian companies and Indian research programs are mostly lagging in terms of innovation. That is what we need to highly concentrate on. So the first thing is we should have a very global knowledge, global interaction. So now everyone is having an hands-on experience how to connect people with internet and conference calls to the other end of the world. So the global knowledge can be shared, integrated, and we can form our solutions. And the other thing, as I mentioned, we need to learn more into cross-departmental knowledge. See, the other most important thing, what happens in terms of industry 4.0, um, India has been considered as a consumer market, very big, larger consumer market for past couple of decades. Now, the next industrial market, the consumer market is Africa. If we take Africa as a consumer market, uh, most of us can say that why not India can manufacture all the goods and ship it to Africa. It is not going to be the case because the production is becoming more and more isolated, and all those whatever the products which we are producing here can be manufactured at their place in a very affordable case. That is how the industry is now opening up. The connecting dots are being reduced, and those things can also be done. So this is a very important case we have to remember, that India is supposed to, in India, we are looking forward to move forwards to a bulk manufacturing and mass production company, mass production area. You might remember Make in India. So those kind of things are going to have a less or marginal success rate, because whatever we develop can be developed anywhere in the world. Okay. So the other thing is, of course, I'm very sure that you have understood most of the 3D printing process and additive manufacturing process for the past couple of days. So I just want to go through a couple of important terms here. So 3D printing and additive manufacturing, where you do a layer by layer addition, is what we call it as additive manufacturing, and the similar name is also can be used termed as 3D printing, rapid prototyping. Everything comes under the same thing. I'm just mentioning the terms and terminologies. So you might be aware of virtual prototyping and physical prototyping. The virtual prototyping is whatever you are doing with your CAD package is called as virtual prototyping, and the physical prototyping is converting those virtual models into a final product output. That is what we call it as a physical prototyping. So generally, there is a very big question: does the conventional manufacturing process is going to be replaced by additive manufacturing process? Here we have to have a little understanding. Conventional manufacturing process are based on the conventional design process. It depends on the design, and it depends on the design and the manufacturing process. So if we want a very complicated models, then we have to get into additive manufacturing. Most of the conventional parts can be will be made using regular manufacturing process. Only the complex models and the outdated models can be derived from additive manufacturing method. So conventional manufacturing process is not going to get outdated or overlooked by additive manufacturing. The other disadvantages of an additive manufacturing process over conventional is the time duration that takes. For example, if I'm making there is a joke also. There is a funny comment also. The process for making a simpler model, it takes additive manufacturing takes nearly 1 hour, 3 hour, or 4 hour process. Whereas in conventional manufacturing process, in that hourly period, we can mass produce the same component. Yes, for sure. For example, if we are taking a propeller blade, in a conventional process, we take a bigger workpiece and we have to machine it completely. Okay, the workpiece will have a larger volume, and also the scrap that is going to be generated using conventional manufacturing process is also going to be on a higher volume. By combining additive and conventional manufacturing, we can create a profile of that blade using additive, and then machine the surface of the propeller blade. We can achieve very lesser scrap, and also in a shorter duration period of time. Okay. Usually this is a flowchart we assume during additive manufacturing or prototyping. You have an idea, and that idea has been converted into an virtual design. That virtual design is being communicated to your printer by a slicing software, and you are going to get an virtual output. physical output. So this is a flow, and I will give couple of examples what ideas we took and how the solutions came out. Okay, and So the other thing is, if we are providing a drawing to our machine floor, we can give a reference model to our manufacturing floor, so that the machine operator doesn't need to communicate with us on a regular basis. All the details will be given in a 3D model also. With the drawing we can give a three-dimensional model, so that they can have a better understanding of drawing and the machining process. So these are the different types of 3D printing processes. A couple of processes you might have heard, like selective layer sintering, stereolithography, digital light processing, polyjet, and fused deposition. I'm going to stick on to fused deposition model, because fused deposition model is the one which gave a very biggest breakthrough of giving an affordable 3D printers. Okay, so these are the two types of printers that we are customized. We are giving out to our customers. Customized 3D printers we are giving out to our customers. One is a Delta model, and the other one is a Cartesian model. So these two printers can be customized to any dimensions that is required. If a customer, most of the printers they come in a standard size, standard dimensions. What we are trying to get into is the market where we can customize the size and printable print volume of a volume of the printer, and also different specifications of a printer. And all these types of material can be used in an FDM machine, right from ABS, PLA, which is the most common material that we are using. PP is other common material for fluid based fluid based containers we use. And all these different materials can be used for our printing process. The other thing is, this is a board which is the brain of our 3D printer, which is a maker board. Generally this board can be used to control any CNC or any 3D printer, and also laser cutting machine or any plotter machine of those types. This board can be customized and reprogrammed. Basically this program controls X, Y, Z, and also an extruder. Single and dual extruder boards are available, and also it controls the temperature of our extruder. Okay, so general types that can be used for 3D printing is, the most common is STL file, and we can use also object files we can use, and also the currently additive manufacturing extension files are also available. In any CAD modeling software, .stl file will be available. So you can simply convert it and you can use it. Um, for slicing software, Cura is the free version. Simplified 3D is a paid version. 3D Build is a default Windows version that is available, and there are many online platforms are available where we can upload our model and get a quotation. If you are okay with the price, they will print it and deliver to your doorstep. That is also available. Most of the machines, all 3D printers use G codes to run in their machine. And additive manufacturing, when we are thinking about in terms of looking study into an additive manufacturing, the new concepts are design for additive manufacturing, designing effective parts with lesser weight. That is nothing but topography optimization, or geometric profiling is a new emerging topic, and the other thing is compliant mechanism. So these are the different types of mechanisms or concepts that are being evolved, that are being derived based on additive manufacturing. Okay, so I'm just going to give you some examples and models that we are going through, the type of customers we are tied up to. These are the components of an industrial textile machine. Exclusively, why what this model is like. The customer is an importer in India. He buys used textile machines from different countries and refurbish those machines, and they will be selling it in India or any other country. So what happens here is most of those machines are very old machines. If the plastic components are broken, they won't be able to identify uh, replacement parts. So what we do there is we take all the broken parts, we redesign it, and then we print it and deliver it to the customer place so that they can replace all the plastic components. So this is like one type of customer we have. The other thing is, so we have the design for additive manufacturing concept. So this is a simple type of bearing. This bearing can be used inside a print. So usually, if it is a ball bearing, the ball bearing needs a support to print. But here, what we can do is without support, we can print the model, and it becomes a functional model. And all this being done in a single print, not an assembly. So we print it in a single stretch, and that model can be used in our assembly. So when we talk about ideas to a product, so for example, this is a model which I took it as an idea. So since I'm more into computational fluid dynamics, most of the time I used to think that I want to study how a wind instrument works. Commonly, the wind instrument like flute and trumpet. Since I'm not into music, I broke down the problem into a simpler problem, how a whistle works. So we all blew a whistle and we are getting a sound, but we are not very sure how that sound is being generated, and what is the mechanism behind that sound. And if I'm going to design a whistle and I'm going to get a prototype, then the process is like we have to design a virtual model, then we have to design a injection molding mold, and then we have to take it to a mold maker, and then we have to get the component out. So after all these process, if my design fails, the entire cost is going to be a loss. So what since we are having a 3D printer, why should not we design the model for ourselves, prototype it, and we can physically do a simple analysis. So it nearly took me 6 hours from uh, studying how to design a vessel, modeling it and 3D printing it and making a little corrections, and for a final output, it took six hours for me. So you can see that I have done a detailed computational fluid research and couple of prototypes, and we have done a couple of modifications, and now we have a product. So in the camera also you can see that this is a whistle that we are giving out. So so this is like a simple idea that has been converted into a product. For example, you can see this is uh, you can see this is a straight whistle, and this is a circular whistle, and now we got a square type whistle. So all are these are the three different types of whistles from what we thought as a simple idea, and that idea has been converted, and we have given an product output. Nearly in the last year, we have did near more than 5,000 whistles in terms of circle and square. So some of us might even think that is it feasible for mass production? Yes, we did nearly 5,000 whistles in during COVID lockdown period itself. We have done 5,000 whistles for a couple of companies, and still we are looking forward for a larger orders in this product alone. Okay. So the other thing is it can be used for a fashion design. The thought, how we are going to put it inside your thought, and how we can convert it into a process. So this is like a fabric design with combined assembly. Also we can do it, and also in single stretch print. Also we can do our pattern, cloth patterns, and everything. So this is an example for component design. So usually a clip will have Usually, a clip will have two left and right component, and then a metal spring. So with this only, a clip can function, right? So what we have done is we have done a simple clip, so which has the same kind of action. So without any assembly or combined parts. Okay, so this thing can be used for cloth hanging and other things. So we use the general PLA only, not an ABS, and this can be modified. The same thing can be modified to any dimensions or any other design. So this is like we call it as compliant design. So giving the same action in a single component, so not as an assembly. In the clip you can see that it is an assembly which has a metal part and other things. This the clip which we have designed doesn't have any metal part. It is a single model, and this can be used. So I'm using it in a larger volume, and now my friends, I've given to a lot of my friends for analyzing also. Still it has a couple of disadvantages in the design. We still have couple of problems, like this loop will break in heavy usage, or in different load conditions. We are still evolving and recorrecting it. So I'm just trying to give simple examples that doesn't need a larger engineering thought. Okay, don't mistake me. I'm just trying to give simple models and simple things that we can give a instant solutions. Okay, so the other thing is we talk about 21st century skills. This is what very much needed now. I would say that for example, a simple example can be like all our grandparents. They don't know how to use a mobile phone. They are used to the basic phone which can call and which can send a simple text message. Our parents know how to use a multimedia phone, but still they are not an expert level. But all our kids are very much expert in those things. They are able to use the multimedia phone in a very extent level for learning, for sharing information and collective growth. So this is like a generation gap, and the knowledge and the skill sets that are lagging in terms of generations. The 21st century skill set is what we are calling as learn, experiment, and execute. All our generation is like learn and experiment. We learned and we experimented it, and we never had a chance to execute it. But now the generation is more like learning, experimenting, and executing. If you may all remember, in our college days, we will be having a C program lab. We type all the codes and we execute it, and we get the numbers in the screen, right? So how come come that C program can be used in terms of mechanism, we never had a chance to implement or execute those kind of things. But now what we are working on is an outcome based learning methodology, which says that don't buy toys for kids. So what the thing is, so instead of buying a toy for your kid, you buy a 3D printer. So when you buy a 3D printer, we can introduce them with the basics of all basic physics and basic design knowledge, and they can evolve their thought into physical forms. Since most of the parents are interested in evolving their own thought process, so integrating a kid's idea with our influence, we can generate more toys, playful toys, knowledge toys, and everything, and that can be converted into an product for our kids and also for other kids. I can even share some example what we have done. So this is a basic sling gun. In Tamil, we call it as undivil. So undivil, usually it is an Y-shaped wooden stick with an rubber tied to it. So we can put a rock and we can hit the targets. So what we have done in the same thing, what we have done is we bought a 5 rupees balloon, which is much thicker than the low cost balloon. So we 3D printed a small mouthpiece like this, and with using beads, we can do the same sling gun effect in this. So this is like one toy that is an design process discussing with kids. Okay, what I'm trying to explain is some of the products we evolved in designing with kids. So the other thing is we can print multiple models any number of times. So if you first create a basic model, then the next two models are multiple replicating. For example, this is like a Pokemon toy, which we downloaded it, and now you can see that the Pokemon family that we didn't buy it, we just downloaded and print a small Pokemon family. This Pokemon family, they can go for an interactive play. So they go for an interactive play with this. So this is one thing, and the other thing is this one is a very interesting one. This is a toy called Otto, and this is my niece. So she does a lot of things like this. So this is a small toy called Otto. It has a Arduino based thing. So she is 8 years old, and she knows how to do a little bit of programming, and all those programming can be transferred to a robot, and that robot can be functionable. So now how we teach her is like the Arduino is the brain of the robot, servo motors or the muscles of the robot, all the plastic components that are being 3D printed or bones of the robot, and the viewfinders and everything, the power sources, the energy for the energy for the robot. So in simpler terms, we can convey what we are trying to teach them, and they can explore the possibilities. Instead of just programming and getting the results in terms of virtual, we can give directly to them the paths, and we can make a lot of different paths. Currently, we are doing couple of other projects also. These are few things. And this is a product. 1 minute. Actually, this is a product which she derived. Okay, this is a product derived by an 8-year-old. What happens is she is more interested in spell bee. So we thought different ways of teaching her about spell bee. The one good tool is Word Plus, which is a fun school product. It has all the alphabets in wooden blocks. So we have to arrange different words uh, so that you get different points to each and every word. So this is a game which we play like every day. So one day she came up with a question. We are able to see, so we can play this toy. But how a blind kid can play this toy? She had this question. Out of her question, I took her to a couple of people. She has been introduced to what is braille, and with a braille teacher she started asking questions, and from that question the braille teacher's output is like, yes, the blind kids need these kind of toys, because the blind kid can communicate very well. They got a very good English communication, but they are very lagging in vocabulary and spellings for those vocabularies. So this is a very important. If this toy comes out, this is a very important toy for them. So uh, we thought and we designed is a peg. So the peg will have a braille letters, braille and alphabet letters on top, so that both a blind kid and a normal kid can interactively play. So this is a thing what we have developed. So see, the innovation process comes with a lot of questions and the lot of transformation process. Okay, so out of this, the other things can be evolved out of auto or hands-on experience with 3D printers, or couple of models I have shown here. So the basic Python and Arduino programming is enough. With basic Arduino kits, Arduino Uno or Arduino Nano is enough for learning. See, what happens here is they know the kid or a student, engineering student for the sake, uh, they can learn what is computer programming. They can learn about circuits, the sensors and everything, and also they will be designing their own mechanisms and functional elements. So this gives a larger learning outcome. Okay. So what we did for COVID, since we are a product and research based institute. So what we did for COVID, that is one question everyone were very much interested in. So this is one product we did. So how we understood how a COVID infection works. So basically, what happens is when you are affected by a COVID virus, the lungs will start getting failed. How the lungs getting started failed is all the internal uh, you get pus that is formed inside your lungs. That pus formation will reduce the functionality of your lung. So in order to overcome that, you need to inflate the lung with more uh, air, what we call it as a continuous pressure. So we need to provide a continuous pressure, and with that continuous pressure, you can lift or you can pump, blow your lungs with the full air capacity. You can see that the device, which is called as a CPAP, addressed to a patient. And in many videos, you can also see a plastic bag that has been put on top of a patient. These are the different CPAPs that are available. So what we did as a small replacement, all these CPAPs need a very larger manufacturing process and also assembly line. So why not we redesign the CPAP with additive manufacturing? For example, the one on the top is a model from Mercedes AMG UK. So this device is being developed by Mercedes in UK. So we contacted them and we got a lot of design inputs from them. So this is being done using an manufacturing output. So conventional manufacturing process. This model is being done by a conventional manufacturing process. From that, we took what are the how the what is the functions of it. So we took those all the functions and we came up with a version 1, and out of that version 1, which took more material and more printing time, we came up with a version 2 with a lesser volume and with much more lesser component. For this, you just need to download it, and you can print it at any nearby 3D printer, FDM printer, and you can print it out. So this is a small workstation how we work in our at home or work from home right now. So this is one simple solution that we came with a small simple CPAP device, and we have given this model to a couple of people right now, and they are yet to be confirmed whether it performs well or not. Okay. And this is a COVID key. You can see it is a simple COVID key. So we used PLA material. So the basic dimension is 6 by 3, and the thickness is 0.5 centimeter. And it can open door locks, lift key. It can be used as a lift key also. And it can carry a load up to 6 kgs and above. So this can be used by doctors and everywhere. And if at all this thing is even if it is being designed for additive manufacturing, this thing can be mass manufactured using injection mold. So the other thing is application. Next, Iraimudi is going to present on medical application. So the most important thing in medical application is topography optimization. So which is a very huge and important area of research where we all can contribute ourselves. If you are interested in structural and finite element analysis, this is the most important area where we can give a lot of inputs. So what we have done is a basic lower jaw, mandible, and we need a replacement brace. So we took the model and we took it for an finite element study, and we came up with a small basic braces that can be replaced. These braces are being 3D printed, metal 3D printed, and the metal 3D printed model will be placed inside the person. So with this, I will finish my presentation. I think. With this, I will finish my presentation, and I am open to question session. So now it is time for questions.
Hello, any questions, participants? Hello.
Uh,
Hello.
yes, we have a WhatsApp group. Okay, so we have a WhatsApp group for basic or general advanced general news about 3D printing, and a lot of faculties and company people are there. I'm just sharing the WhatsApp link. You can join to the WhatsApp group, and whatever questions you have in that group, you can ask with us. We are ready to support you out on that also. So, any questions regarding 3D printing or any of the above process, you can ask. Not only from my presentation, from yesterday's presentation also. If anybody got a question, I'm happy to answer it.
Hello. Hello, sir. Hello.
Yes, sir.
So any questions from participants? Sir, what about the cost, sir? We are going to do that 3D printing.
Sir,
See, you told that,
basically the machine cost, a decent machine will cost from 50,000. FDM machine will cost you from 50,000 and above. A basic machine, and a reasonable machine can cost you from around 2.5 lakhs and above. We got FDM machines at a cost of even 5 lakhs, 10 lakhs, and 50 lakhs. It depends on the accuracy output of it. Okay,
Okay, sir.
what is the kind of output accuracy we are looking forward, and other things. For example, I can show you a cost of metal 3D printing. I got a small. So if we take metal 3D printing, which is so this is a general cost range of a metal 3D printer. A normal desktop metal 3D printer,
Showing in
which,
the showing in the presentation, sir. Hello.
yes sir.
It
Okay,
is not visible, sir. It is not visible.
okay, 1 minute. So now you can see the presentation, I guess. So this is a variant of a metal 3D printer.
Okay.
Desktop metal 3D printer will cost you around 60,000 US dollars. This is
Okay.
an FDM based 3D print, 3D desktop metal 3D printer, and
Okay.
MaxForge, which will cost you around 99,500. And we got a 3D system which cost you around 6 lakh and 80,000 US dollars. So those are
Okay.
common 3D printers available based on metal 3D printers. Okay.
Okay, sir.
Hello, good morning, sir. I am Manik Chandra Das. I have one question, sir.
Okay.
Hello. Acha.
Yes, please. Yes, please.
Sir, to make an object using FDM method at minimum time, what will be the optimized parameter for say build orientation or speed of the nozzle
See,
or
see, see. Your audio is with a little bit of noise.
hello, is it audible now?
Yeah, yeah.
Am I? Acha. Sir,
Can
to
you be
my
little slow so that you got a lot of noise around? So can you be little slow, please?
all right, sir. Sir, I am asking to make an object using FDM method at minimum time. How to
Okay.
what will be the optimized parameter in respect of say build orientation or speed of the nozzles, etc.
Mm, okay. See, 1 minute. Let me open Cura first. Okay. 1 minute. See, for example, I will take a simple model. Okay. So the optimum that time or for example, I will take a small model. Okay, the vessel itself. So, for example, if I'm going to print this model, so for example, the standard vessel, I'm going to calculate the time for it. You can see that for this model, it is a very simple model. It is taking 28 minutes for this to print. Okay, so while printing this model, there are few things I have to remember. Okay, so if I'm not considered about the tolerance of my print. Okay, so I can print this model at a layer height of 0.35. Sorry, so for my machine spec, 0.3 is a maximum limit. So I'm going to print this at a 0.3. Okay. So what happens when it's printed at 0.3? It takes only 15 minutes to print this model. But my model is not going to be functionally successful because I need a very higher tolerance at this chamber. So I cannot go above 1.15. So this one I identified out of the printing mistakes I done. Okay, so I did a whistle at a layer thickness of 0.05, and then at 1, and then at 1.5, and then at 2.25, and then zero point 0.3. So I found out that at 0.15, above that spec, if I am trying to print, my print is not going to be functionally working. Okay, so this is one parameter where you can control your time, and at the same time you have to remember the functionality of your model also. The other parameter is the printing speed and also the thickness of your shell thickness of your model. So for example, you can see I can increase from 60 to 120. You can see I can save another couple of minutes in this. So you can see I have saved a minute out of it. And then if I say my shell thickness is 0.5, I can for this model it is going to be 0. For example, for this model it is optimum. So the other parameter can be, so these are the few parameters that you can control, and the other thing is the direction of your print. Okay, for example, the same this whistle can be printed in this direction also. So last time it was 28 minutes, and now we can see that we can recalculate it, and you can find out that the minutes are going to be an higher one. So the same model is going to take 2 hours and 1 minute. So the orientation, the layer thickness, and the print speed and the fill density, all these can be taken as a parameter for our efficient design. Okay, we'll take one model. And if it is scalable, then no issues. You can even scale it if it is okay for you. For fill density, I'm trying to get a model. Okay. Have I answered you, Mr. Manik?
Yes, sir. Yes, sir.
Okay.
I have got my answer, but there is one question, sir. Uh,
No.
for different orientation, will there be any change in mechanical properties, like say strength,
That is
toughness,
a very good
etc.?
question. Yes, yes. There is going to be a change in physical property of it. See, what happens here is we are going to do a layer by layer printing. Usually, in our if you are loading as per the loading condition, if I am trying to print 1 minute, 1 minute, I will take a model. This concept we call it as a DFMA, designed for additive manufacturing. See, for example, let me take a pig like this. Okay, if I am printing in this orientation, I will have more structural capability. Okay, because all my layers are going to be acting perpendicular to my force, right? My force is going to be applied here in this phase. The force will be applied. So what happens is all the layers are parallel to the force of the direction of the force. Okay, if I print the same model in this direction, okay, and I'm applying a force here, what happens is my layer will be perpendicular to the force, and the structurally it will be very weak, and there is a higher possibility of breakage. Okay, this, if you are printing the same product and applying the force in this area, the product will fail instantly rather than in this orientation. Okay, so that is a very good thing you have asked. Okay, this orientation is very good for the load condition. Okay, so you have to remember what is your load condition, and for what load condition uh, you are going to do the model. In the same way, if we are trying to print any cylindrical model, it is very good to do orientation in this direction rather than in this direction. Okay,
Okay, thank you very
so
much.
this thing we are not going to appreciate. Okay, so we will be appreciating the layer along the side. This is also okay for our print. Okay,
Thank you very much, sir.
thank
Thank
you.
you. Uh,
Any other question?
Sir, good morning, sir.
Good morning, sir. Sir,
Myself,
please.
Dr. Rajesh from Tirupati.
Okay, sir.
Sir, my question is actually, are there any readily available metal 3D printers, sir?
Yes, sir, that are available, sir. So I have
May I
shown
know
in my
which
presentation, sir.
okay, sir. Which location, sir? With you, it is available, sir.
Yes, sir, we can provide, sir. We got a metal 3D printer from 3D Systems,
Uh-huh.
which will approximately cost you around. I can provide you with a quotation, sir. No problem.
Okay. Sir, are there any readily available metals, sir? That is the wire rims.
You mean the FDM models?
Yes, sir.
FDM 3D printers are available.
Uh-huh.
Metal 3D printers. Who is that?
Hello. Hello.
Can you mute yourself? Okay. So metal FDM metal 3D printers are available. The problem with an FDM metal 3D printer is, 1 minute, I'll show you how a FDM metal 3D printer works. So this is a process. So this is a process of an metal FDM 3D printer. What happens here is we get the same filament with concentration of metal particles in it. The same PLA filament with metal particles filled into it. In this method, what we do is we roughly print the model. Okay, so using a normal FDM machine, from the print will be then transferred to a debinder, where all the extra PLA material or the ABS material which is used for fusion will be evaporated in a debinder, and from the debinder we will be taking it to a sintering furnace. In sintering furnace only, all the metal particles will bind together. So this is kind of a metal FDM process that we can do. Okay, The real problem with an FDM metal 3D printing process is the cost. For example, if we have a metal 3D printer, the metal in a powder form, for example, for stainless steel, a kg for 500 grams, it will cost you 8,000 rupees. The raw material. General implants, medical implants, which comes under a titanium alloy, will cost you around 25,000 rupees a kg. In the same similar case, if you are going for an FDM based metal 3D metal filament, aluminum will cost you half a kg. Okay, will cost you around 45,000 rupees. High carbon steel will cost you around 16,000 rupees. Stainless steel will cost you around 29,000 rupees, and titanium will cost you about an lakh. So this is where still the FDM 3D printing was not much affordable. So what we can do is we can take your case study, like if you got a model, okay, so we can take it as a case study and we can identify a suitable alternative solution for it. Even FDM also, in FDM printer also, we can print it in a print using basic PLA, and we can go for an immersed casting or pressure die casting model. So it depends on your model. So currently, because of the raw material cost, if it is okay for you, we can still go for an FDM based metal 3D printer. Okay. Did I answer you, Mr. Rajesh? I remember.
Yes, sir. Yes, sir. I
Yes,
have
sir.
got you. But actually,
So
sir, can you able to produce any composite materials, sir? That is my
uh,
last question.
composite in the sense, composite in
Aluminum
the sense.
plus silicon carbide
Uh,
reinforcements addition. Because you have
Not sure about it, sir. Not sure
only.
about it.
Okay, sir.
Not sure about it. Because
Because
what happens here is FDM machines comes with dual extruders. Okay. In that case, if we are going for dual filament like aluminum with high carbon steel, yes, sure we can put put them together, but only the sintering process is what going to determine the structural capability of it.
no, sir,
So
actually,
that
if you are
is
going for
where.
extruder for aluminum, sir, the
Okay.
temperature is only 750. But if you are going for any abrasive particles like silicon carbide, it may
Yes,
go
sir.
around 2000 or 3000 degrees centigrade.
Yes,
Then
sir.
is
Sir,
possible, sir?
that is based on pure metal 3D printing. What I'm
Ah,
talking to you about is a FTM
FDM.
based printer, where we combine in a
To
ratio.
extruder. Yes, sir. Yes,
Okay,
exactly.
PLA like 20 percentage of PLA and 80 percentage of metal powder. So that
Oh,
kind of
okay, okay.
combination is what we are talking here in terms of FDM based 3D printer. And the other thing
Right,
is
sir.
a desktop metal studio that is available at 60,000 rupees on a FDM one. But still, after this, you need a couple of accessories for debinding and sintering furnace. So that is going to cost you extra on this. Okay.
Okay, sir. Thank you, sir.
Thank you. So any other questions, please?
Hello, hello, sir.
Yes, sir. Yes, sir.
So, what is the latest technology using in the additive manufacturing, sir?
So it is completely still evolving. Every day we are coming up with new technologies. I will suggest be in a WhatsApp group. So in our WhatsApp group, we will update it constantly. Okay.
Okay, sir. Okay, sir. Okay,
Okay.
okay, sir. So, any other questions, sir? Hello, any other questions, sir? Okay.
So still, if you want any queries or any thing regarding um, uh, additive manufacturing or FEA CFD, you can still contact us. So
Okay.
I've given my number and other details in the
Okay.
slide, and also I have shared the WhatsApp group chat ID also,
Okay, sir.
so you can get in touch with us. Okay,
Okay, sir.
we can give you quotations for 3D printers based on AACT spec. So also we can provide, and we can give a lab setup for additive and industry 4.0 for mechanical and electrical students combined together. Okay.
Okay, sir. Thank you, sir. Okay,
Okay.
sir.
So if you still got any questions, you can pop it in our group chat also. Okay.
Okay, sir. Okay, sir. So thank you, sir.
Thank you.
Thank
Thank you.
you.
Very
Sir, the session was so nice.
Thank you.
I think all the participants enjoyed and they understand the concept very well. Thank you for your enlightening speech and enthusiastic participation. Once again, I thank you. Thank you very much, sir. Thank you, sir.
Thank you. Thank you, man.
Thank you, sir. Thanks. Hello, dear participants. Hello, hello, participants. Good morning.
Good morning. Good morning.
Good morning, sir. Sir, you can take the photo. You switch on the video, sir. Just you can take the photo of this FDP. Please come on the video, sir. Just you can share it and we can post in the, our. Uh, yes, sir. Yes. Hello. Can you hear my voice? Hello. Hello.
Yes, sir. Yes, sir. We are getting
Okay.
your voice.
Yes, sir. Yes. Okay, sir. Okay. Thank you for this. Yes. Sir, uh, we're having that test afternoon. Hello.
Yes,
For
sir, you
that,
are audible, sir.
yes, yes. Sir, for that, we read a validation function. First, we keep the validation function, and after that, we are going for the test, or complete the test, and after go for the validation, sir. Which one you take first? Hello? Hello, sir?
We
You
can
go for
have the
a,
test first.
you have the test first. Sir, first you completed the validation, sir, because I posted the test in the WhatsApp group or chat box.
Okay, sir.
3 o'clock. 3 to 4
Okay.
we can 3 to 4 we can keep the test. First you completed the validation uh, around 2:20 or 2:30, and just
Okay,
half
sir.
an hour, 2:30 to 3 you completed the validation. After that I posted that test, and we completed the test within the 1 hour, sir.
Sir, that is not an issue, sir. But you please give us some time, sir, because we are involved in college activities, sir.
Okay,
At
sir.
least up
Okay.
to 5 or 6 o'clock, you can extend the time, sir. Even though you are giving only 30 questions, but
Yes,
you
sir.
let us give the permission to have the more time, sir.
That's why I'm
Ah,
giving only 30 questions. So it is a
it's okay,
complete.
sir. No problem.
Yes, yes, sir.
Even if the link is kept open, means, sir, after going to home also, we can able to attend the test. That is my request, sir. If possible, otherwise,
Okay,
as you wish, sir. No problem.
okay, sir. Okay, okay.
Because today is working day, sir. Today is not second Saturday.
Yes,
We
sir.
are all
We
working.
also we are also having the college, sir.
Please, sir. Even the students are also there. We are having labs and all. If
Yes, sir.
possible, you extend the time. Otherwise, as you wish, sir.
Okay,
Because
sir.
you are
Up
the
to,
coordinator, sir.
sir.
No
Okay,
problem.
sir. Up to 6 we can keep, sir.
Please, sir. You please.
3 to 6.
That is better, sir. After reaching
Yes,
one's
sir.
home, sit, relax, and then we can able to write the answers.
Okay, sir. Okay, sir. Up to
That
6,
is
I will.
from our request. Thank you,
All
sir.
right,
Thank
sir.
you.
All right. It will be nice. It will be nice.
Okay, sir. 3 to 6, I will keep, sir. First, we keep the validation function, sir. No problem.
Yes, sir. Yes, sir. We'll attend the validity. No issues, sir.
Okay, sir. You can start at 2:30, sir. We
2:30, all right.
we okay. We again we have the test at 3 o'clock. Half an hour for the validation function, sir. That is the thing I'm going to tell. To share that. If it is okay, sir. It is okay. Any
Okay,
issue?
sir. No problem.
Okay, okay, sir. Okay.
Yes, sir.
Okay. Okay, sir. Next session we're going to start at 11:45 in the same link, sir.
All
Okay,
right.
sir.
All right.
Okay,
All
okay.
right.
Thank you.
Thank you.
Thank you, sir. Thank you, sir. Okay, sir.
Thank you, sir.
Thank you, sir. Thanks.